Hi friends, as you all know, there is going to be notification for AE APPSC very shortly. So it is a common paper for civil and mechanical engineering graduates BTech. Okay, the qualification you must be knowing that it is BTech. Okay, civil and mechanical posts are there. About 190 posts are there. So for this common paper, you are having the major syllabus is one is strength of materials and second one is the fluid mechanics. So let us have a beginning today for your simple stresses and strains, which is the first topic. Okay, let us see this. So what is this? Strength. What is the strength? So it is the load carrying capacity of a material is called the strength. For example, it is able to resist. Let us say it can take, let us say, 20 tons. So that is called your the load carrying capacity. If it is able to take 20 tons without any problem, so that is the maximum capacity. That is called the load carrying capacity of a material is called strength. Okay. So let us say, for example, the maximum load that it can take. So after which, let us say it is going to break or whatever it is. So for ductile materials, we are going to take it may break, but before undergoing a lot of plastic deformation, right? First, it will be in the elastic state, then it will go into plastic state, then it will go into the necking state, and then it will finally break. So it is the maximum load that a material can take is called the it is the what you call strength. Next, the ability of a part or element of a structure to resist failure. So this is also called a strength. So this is another way of defining the strength. Okay, next comes stiffness. The ability to resist deformation is called the your stiffness. For example, it is let us say it is resisting the deformation. For example, let us say if you are applying a load of let us say 10 kilonewtons on a bar of say 1 meter, right? So it is undergoing a deformation of let us say 1 mm. So it is able to, for example, I have given one example, right? It is able to resist the deformation, right? That is called your stiffness. So what are the units of stiffness? It is the load per unit deflection. For example, load is in newtons and deflection is in mm. Newton per mm is the units of the stiffness. So we are going to make some assumptions when you are strength calculations. When you are making the strength calculation, there are some assumptions. So what are the assumptions? The material of the body has a solid continuous structure. That means there is no material defects. So that means what is the meaning of this? It is a continuous structure, means it is not having any material defects like for example cracks or blowholes or porosity or whatever it is, right? Next is your within the limits of the part of the body, the material is homogeneous and isotropic. So what is the meaning of isotropic? Any material has having elastic properties uniformly in all the direction. It is called the isotropic material. Similarly, it is homogeneous. That means it is not heterogeneous. Anything which is not heterogeneous is called the homogeneous. Now there are no internal forces in the body prior to the loading. So this is also one more important assumption, that there are no internal forces. Then if there are some internal forces, it is going to affect the load carrying capacity. So we are going to make an assumption that there are no internal forces in the body prior to loading. Next, there is a principle of superposition. So it is going to assume that the principle of superposition is valid. What is the meaning of what is this principle of superposition? So it is valid only when the deformations are small compared to dimensions of the body and deformations are linear functions of the acting force. So here we are going to make an assumption that the deformation is a function of the acting force and it is proportional to the acting force. And also we are going to assume that deformations are small compared to dimension of the body. For example, the dimension of the body is 1 meter, example, right? So let us say it is undergoing a deformation of 0.05 mm. So if you compare 0.05 mm with 1 meter, it is very negligible. Yes or no? If you take the ratio, how much it is going to come? 1 meter by say 0.05 mm. So 1 meter means 1000 mm by 0.05. It is going to be say 50,000 or more than that. Okay. So like that. So this is another assumption, that is principle of superposition is going to be valid. Now Saint Venant principle is valid. What is this Saint Venant principle? So it is basically there is one theory of failure called Saint Venant's theory. It is also called maximum principal strain theory. So let us discuss about that afterwards, but it is going to be related with the strain. So now comes stress. So we are going to define stress. What is stress? The internal resistance offered by a body against deformation is called the stress. So for example, you are applying a load, let us say for example 1000 newtons or 1 kilonewtons. So it is able to, if it is resisting that particular force, so the internal resistance, so when you are trying to pull a body, it is going to develop a resistance to undergo deformation. So that resistance is called the stress. So mathematically I can define the stress as the force by area. Actually you have to take the normal area, of course. So force by area is going to be taken as a stress. So the units of force are Newton, and units of area if you are taking as mm square, Newton per mm square is the unit of the stress. So we also know that Newton per mm square, 1 Newton per mm square is equal to 1 megapascal. So if I go to the dimensions, what is the dimensional formula? So force by area. For what is force? Mass into acceleration. What are the dimensions of acceleration? L t minus 2. L by t square. L t minus 2. What are the units of mass? M. So now stress units are mass by area. So ml t minus 2 is the force units, and area L square. So ml t minus 2 by L square. So ml inverse t minus 2, t to the power of minus 2. So that is how I am going to get the dimensions of the stress. So now what are the types of stresses? Let us see what are the types of stresses in any material that will be undergoing. So it is based on the type of load. So if it is subjected to tensile load or the pull, that is called the tensile stress. If it is subjected to push, that is called the compressive stress. It is subjected to a load which is parallel to the its axis, for example, right, axis of the deformation, then that is called the shear stress, because it is going to shear the material. Now if you are applying a moment, it is subjected to what is called the bending stress. So the stress which is developed in the body because of the bending moment or the bending is called the bending stress. By the way, what is the bending moment? It is the load into perpendicular distance. For example, you want to take the bending moment at any point which is subjected to loading. So if you multiply the force acting and the perpendicular distance between the point to that the line of action of force, you are going to get the bending moment. So what are the units of bending moment? Load into perpendicular distance. Load will be in newtons and distance will be in meters. So if I take the units, it will be Newton meters. But you know that Newton meters is also joule, but you should not say joules because it is after all the moment, force into perpendicular distance. Okay. So in this video, what we have discussed, boys, so we have discussed about the basic introduction to the your first topic in the strength of materials for your AE examination. So what is that? It is the simple stresses in your strength of materials. So we have talked about the what is strength, we have talked about the what is stiffness, and we also talked about the what is the stress, and also we have we have also discussed about the different types of stresses a material can be subjected to during the during the service. So during its service, any material can be subjected to various types of stress are there. Some more stress also there. We will discuss in the next topic. That means next video. That means, for example, it may be subjected to tensile, it may be subjected to thermal stress. The stress developed in the body because if the deformation due to temperature it is restricted, the stresses are developed. So what is that stress are called? So those stresses are called temperature stresses or thermal stresses. For example, any object is coming and hitting a particular body or material, so it will be subjected to the stress that is called impact stress. The stress due to the impact loading is called the impact stress. So by the way, what is impact loading? So anything coming and hitting, definitely it is going to act. The lot of force is going to act on that body. So it is subjected to when the material is subjected to impact load, which is due to the motion of the body or kinetic energy of the body. Okay, so it will be subjected to impact stress. So impact force by impact force by the resisting area is going to give the impact stress. Okay, so in the next video we are going to talk about more about our next topic will be we will be discussing in the next video. Okay, boys. So if you like my channel, please like, share, subscribe, and also share among your groups and contacts. Once again, let us meet in a good video very shortly for your subject simple stress and strains for your strength of material subject, which is there for your common paper for your civil and mechanical engineering graduates. Okay, boys. So once again, let us meet in a very good video about subject video for your strength of materials. We have started today introduction, and thanks for watching my video. Once again, wish you good luck, all the best.